Let's get to our first speaker now. He is the Executive Director with the Industrial Internet Council. Please give a warm round of applause and no pinching for Mr. Richard Soley. Have fun.
Thank you. Good morning. Thanks for joining us today. Anybody already know what the Industrial Internet is? Anybody know what St. Patrick's Day is? Yeah? I don't care, I'm Jewish. Anybody still awake? We only have two heads nodding. Okay. I'm going to give you a reason to call it the Industrial Internet instead of one of all of these names that you've heard over the years, like Cyber Physical Systems, Internet Plus, Internet Value Chain Industry Value Chain Initiative, or here in Germany, Industry 4.0. You've heard of Industry 4.0, Industry 4.0, yeah? Nobody. Just this one gentleman. He's the only one listening. Everybody else is having breakfast. Okay, thank you very much, sir. I'm just going to talk to you. I'm going to give you a way to think about IoT impacting industrial systems, because I think that you haven't heard enough about industrial systems impact of IoT. But I like to start with a quote from a well-known man. Anybody ever heard of Bill Gates? That's 3 people. Very good. I'll tell Bill when I see him. In 1995, Mr. Gates, if you haven't heard of him, by the way, he's the son of the person who used to be the richest man in the state of Washington in the United States. Okay, no jokes, I'm sorry. 1995, he was asked by a reporter, why doesn't Microsoft have an internet division? It was a perfectly good question, and he gave a perfectly good answer. Why would I have an internet division? It would be like having an electricity division. I, at the time, was reading about the history of electrical power adoption in Western Europe and in the United States. And in fact, many companies between 1900 and 1910 had electricity divisions. Companies like Colgate-Palmolive and so forth, because they were trying to figure out how to use that technology to impact all of their operations, their manufacture, their distribution, their retail, understanding their customers, and so forth. None of them have electricity divisions anymore, or they do, but they're called janitors. So that has become a required part of operations. And I think Gates, being a very smart guy, figured that out as well. And in 1999, he wrote this line in a letter to all of his employees. He said, "The internet changes everything." Everybody agree with that? Well, I think we can come up with some examples where the internet has changed everything. Here are some. The most obvious is in the upper left-hand corner. For those of you who still have a lot of hair, that would be a boombox, and that's how we used to listen to music. I know it's, for those of you who are younger, this will be a big surprise, but music used to be delivered in physical form. They were called 8-track tapes. Okay, no more jokes, maybe a few more jokes. Records and CDs and so forth, and now they're delivered completely online. And we listen to music on computers. That doesn't necessarily look like that laptop computer, more likely it looks like this computer. Okay, now, this is a BlackBerry, I'll explain later. I like Canadian products, thank you, yes, there's another BlackBerry. We read news, we watch television, or what used to be called television, on computers. We read newspapers, but probably only online. I no longer read a paper newspaper like many of you. I read my news in the morning from the internet. Even making music is no longer done with physical devices. It's entirely electronic. So you would think that Gates's prediction, which is the internet changes everything, was true, but in fact, I'm going to tell you that it was not. Anybody recognize this device? We have any process people in the room? Nobody. So this is a device that I worked with in 1979 and 1980 when I was 2 years old. Thank you for the one laugh in the back, yes, thank you. On the left-hand side, that is a programmable logic controller. Normally we just call it a PLC. They're used for managing discrete manufacturing lines. So for making, in this example, actually, this is a real device, a picture I took in 1980 of a device that was running a manufacturing line that was making brake linings at a General Motors plant outside of Detroit, which is a city in the United States where they used to make cars. Thank you, yes. Thank you. You're just slow, right? I got it now, okay, thank you. There's an interesting thing about this device. First of all, even though it was a computer, inside, in fact, it had a Motorola 68000 chip like many computers of the time. The way you program this device was completely different. The programming language is that strange notation there. It's something called ladder logic or ladder diagrams. But even more important, the way that it connects to the rest of the plant, what we used to call manufacturing resource planning and we now call enterprise resource planning systems, is it didn't. If you wanted to take advantage of the knowledge that was essentially inside that box, what the just-in-time deliveries looked like, what just-in-time output from the factory looked like for connecting with your customers, what parts of the plant floor were in use and what parts of the plant floor were not, and what devices were being used on the floor, what people were using, what tools on the floor, and so forth, none of that information was directly connected to the enterprise planning. In fact, what normally happened was it would be printed out, and then it would be walked across the floor using a high technology we call sneakernet, and typed back in. Fortunately, with an average error rate of 40%. 40, a lot. That's a lot. So here we are in 2016, 36 years later, and it hasn't changed. The programming language is strange. The box is now blue, which is really nice. The old machine was made by a company called Modicon. It has been bought and sold many times. It's now made by a company called Schneider. That would be a French company with a German name in the United States. It doesn't connect to the information resources of the plant. This is an example where the internet has changed nothing. It has changed nothing, and this is a huge market. This is billions and billions of euro a year. This is an opportunity, and we can see how the internet has changed so many other markets, typically entertainment and information delivery, but it hasn't changed some of these markets. For example, oil and gas exploration. They have serious problems in information delivery. For example, in offshore oil drilling platforms, they need to make decisions about drilling every 1/10 of a second. Do you push the drill harder? Do you pull the drill up? Do you change the bit? Do you change the drilling mud? Every 1/10 of a second, they have to make a decision. But it turns out that you don't want too much computing platform on the oil drilling platform because it's wet, it's salt water, it vibrates, it's hot. So typically, they use computing resources on shore, and they use a connection through a geosynchronous satellite to get the information back and forth, with a round-trip time between 1/2 and 1 second. Hard to make a decision every 1/10 of a second in that situation. There are examples like the jet engine market. Well, you see some of the examples. There's already a lot of information being collected. For example, in the rail space, here in Germany, in Berlin last year, I heard a wonderful presentation by a General Electric executive who said that their diesel-electric locomotives, these are large devices, collect 9 million points of data every second. So I asked him how much of that is actually used in ensuring that the train is more efficient. And he said, 3. And I said, that's pretty good, 1/3 of the data. He said, no, 3. So 9 million points of data every second thrown away. Think about what you could do if you knew the exact efficiency rating of the engine at this moment as opposed to the average efficiency of that engine when it's manufactured. What's missing is internet thinking. What's missing is the connection between our internet resources, our information resources, and our operational resources in these markets, in these operational systems where the internet has had no effect. So this is the way to think about it. In the 19th century, roughly from 1840 to 1900, there was a revolution in the world called the Industrial Revolution. Have some of you read about it? Anybody? Yeah, okay. Only this lady. Thank you very much, ma'am. I appreciate it. The Industrial Revolution changed a lot. For example, it moved the industrial strength, that is human power, into machine power, starting first with looms. Mechanical looms were the first thing that happened. Textile development. And there was a disruption, by the way. Many, many jobs were lost. Here in Germany, there was a movement against these automated looms, the Jacquard looms. The movement was called the Weavers. In England, there was a similar movement called the Luddites, destroying looms because they were destroying jobs. And it is true that jobs were destroyed. Far more jobs were created than destroyed. This is something that doesn't get talked about enough. By 1900, there were many, many, many more jobs, actually 3 to 5 times as many jobs, because of this enormous leap in productivity that you see here, between 2.5 and 4 times leap in productivity, depending on which economist you don't believe. I don't believe any of them. Yeah, thank you. You agree. But still, there was an enormous leap in productivity. So you have new jobs that are created to build and maintain these automated looms, and in the move from steam power to internal combustion and then electricity, for example. But more importantly, because you have a huge leap in productivity, you have a huge leap in consumer demand, and a huge leap in consumer demand means that you create more jobs. That's what happened in the Industrial Revolution. 100 years later, we saw it again at the end of the 20th century with the Internet Revolution, moving human connectivity to machine connectivity, not intelligence. We're going to hear about that this afternoon, I understand. Having worked as an expert system developer in the 1980s, a mere 35 years ago, I'm not convinced that it's going to replace human intelligence. But I do know that human connectivity is greatly enhanced with machine connectivity. And again, we saw this huge leap in productivity, and again, we saw disruptions in the marketplace. For example, in the United States, there are essentially no bookstores left. The bookstores have evaporated, and with them, the jobs at the bookstores. But new jobs were created. In 1990, there weren't many webmasters in the world. There was one. His name was Tim. His name is now Sir Tim. Thank you, sir. And we got one person who got that one. We'll explain all of the jokes later. That will make them really funny. There are now tens of millions of webmasters in the world. So that has changed. But more importantly, this leap in productivity means there's been a leap in consumer demand and a leap in jobs as well. We think if you take this internet revolution and add it to the industrial revolution, you get something we call the industrial internet. We think there's going to be a huge leap in productivity, and we also think there's going to be disruption in the job market as well. I'm always asked, first question, what will be the first market disrupted? And I always say, I have no idea. But I do know some that will be disrupted, and the most obvious is when we have self-driving cars that not only drive themselves, but talk to each other to avoid accidents and talk to the roadbed to know where the construction is 5 kilometers ahead. That is going to have severe impact on the taxi drivers. The job of a taxi driver will be to find another job. I think that government's jobs should be involved in ensuring that people are trained flexibly because we don't know what the new jobs are going to look like. We've already seen a huge impact of Internet of Things technology in consumer devices. I'm sure many of you are wearing Fitbit devices that you have never looked at since the day you opened the package. 10,000 steps, that's all I know. There's obviously a market there, but there's a huge untapped market today on the left side of this picture, and that's industrial application of Internet of Things. That's manufacturing, that's transportation, that's healthcare device integration, and I'll give you some specific examples at the end. How big is that market? Thank you for asking. Well, there are many different ways to measure that market, but I like the report that was published by General Electric in 2012. It was published not by a technical person, but by their chief economist, a man by the name of Marco Nunziata, very common German name. That will be the last joke that we explain at the end, so you have to wait. He wrote a wonderful report on looking at the gross domestic product, the GDP of the world, to see how much of it is currently unaffected by internet technology, by internet thinking. And he came up with a number of 46%, 70 trillion US dollar GDP of the world in 2012. That is a $32.3 trillion opportunity. 1% swing in $32.3 trillion, for those of you who don't want to do the math, $323 billion a year. And that looks pretty much like the other prognostications on this picture. Gartner says incremental revenue of about $300 billion. By 2020, that's only 4 years from now. That's a huge impact. $36 trillion in operating cost savings, according to McKinsey Global Institute. These are enormous numbers and numbers worth going after. Again, whether you call it cyber-physical systems, as it's typically called in the United States, Internet of Things, which is a more international word, Industry 4.0 or Industry 4.0. In Japan, it's often called the Industry Value Chain Initiative. China has just stopped calling it Internet Plus and is now calling it China Industry 2025. In France, it's called Industrie du Futur. Whatever you call it, it's adding internet thinking to industrial systems, and the opportunities are immense. Where do those opportunities come from? I think most importantly is the first thing on this slide, the revenue generation opportunity. If you go to General Electric or to Rolls-Royce today to buy a jet engine, and I'm sure many of you have done that. Anybody ever bought a jet engine? Just checking the audience. They will sell it to the way that they've always sold it to you, if you like, which is they'll sell you the jet for about 80% of the value of the jet. And they take that loss because for the next 25 to 50 years, depending on the life of the engine, they'll sell you spare parts 4 to 5 times the cost of the engine. And that's where the margin is. Those two companies, however, if you go to them today, they will say, if you prefer, we will sell you that engine on the basis of propulsion. That is, tens of thousands of pounds of propulsion over a certain number of hours and guarantee a certain amount of fuel use. In fact, General Electric is currently running a special where the fuel use guarantee drops by 1% per year for the life of the engine. Why do they do that? Which I call propulsion as a service, by the way, for those of you who like cloud terminology. They do that because that way they continue to own the engine. They continue to, over the life of the engine, to know exactly how the efficiency of the engine is. They get all of the real-time data from the engine, and they can make sure that it is maximally efficient. That's the opportunity, and that's a revenue opportunity. Of course, it changes the way you're no longer capitalizing the purchase of the engine. It's now a lease or operating lease. So it changes the way the jet manufacturer takes the sale. They have to take it as a lease rather than a sale. Changes the way the airline operates. But this is what airlines do with their aircraft anyway today. Even if they do buy aircraft, they typically sell them to a leasing company and lease them back. This will lead, within about 30 to 40 years, to increase customer satisfaction to the point where products will no longer fail. Because if they do fail, if they're going to fail, or even if a part of them fails, you will receive notice of that beforehand through predictive analytics. Because the manufacturer, rather than going through a chain of salespeople, it continues the connection, the relationship with the product over the long term and knows when that product is going to fail and makes sure it doesn't while it's in your use. That's a huge change in the marketplace. How do we get there? How do we ensure that the connectivity providers and the technology providers and the big data companies that you see over in Hall 6, the research organizations, the systems integrators, the government agencies, how do we ensure that they build the right one-on-one relationships to make sure that there are standards, that there is interoperability, that security actually works, that privacy is maintained? Well, we could hope that this picture would happen, that they would connect to each other one-on-one and make those relationships work, but we all know that is not going to happen. So what we propose is something called the Industrial Internet Consortium. Accelerate the adoption of Internet of Things technology in industrial systems by bringing them together to create an ecosystem of organizations and do what? Well, thank you for asking. What we think they should do is actually test the ideas. That's our mission statement at the top there, but the only important part of that mission statement is the last 3 words, transformational business outcomes. What is the real impact of using Internet of Things in industrial systems like manufacturing systems, healthcare device integration systems, transportation systems, smart cities? Well, you could guess and you could try to develop standards ab initio before you actually develop the systems, but it makes much more sense to try your ideas out. If it fails, that's fine. Failure is a necessary ingredient to success. But if it succeeds, you've learned something, and you've learned more important than technology, you've learned about disruptive new products and services. You've learned how to answer that question before, which markets are going to be disrupted first. So almost exactly 2 years ago, March 27th, 2014, these 5 companies, AT&T, Cisco, General Electric, IBM, and Intel, decided to get together to develop this Industrial Internet Consortium and try their ideas and invite others to participate, even competitors to participate, to sort of make a sandbox where they could apply use cases for Internet of Things technology in industrial systems. And this is now an open process that anyone can join. At the end of the first year, March last year, we had 100 members, and today we have about 254 members this morning. Leading this pack is a list of founders and contributing members and other members of our board of directors, our steering committee, General Electric, IBM, Intel, SAP, Schneider, Bosch, Fujitsu, MITRE, and RTI, as you see. But now it's a much larger process than just these 9. Of our 250-some members, roughly 40% are large companies. I like to point out that they're not just IT vendors, they're not just software companies. So yes, sure, you see Oracle and Symantec and Microsoft and IBM and so forth. But you also see the world's largest copper miner in the upper left-hand corner, Codelco. Why does a copper miner want to see what happens with Internet of Things in the mining business? Because they know they're going to be disrupted. They want to do the disruption themselves rather than wait for others to disrupt their marketplaces. The best way to predict the future is to invent the future. You see Haier, for example, a manufacturer of white goods, dishwashers and washing machines and dryers and so forth. You see, for example, Toyota. You may have heard of them. They make cars in Kentucky in the United States. It's true, actually. But 55% of our members are actually small companies. Of those 250-some companies, these are many, not all, of our small company members. These are companies that are under $50 million or 50 million euro. You might call them Mittelstand here in Germany. These companies also participate because they're bringing ideas that aren't necessarily coming from even the most innovative of large companies. So you see here companies that make RFID tags. They're companies that are small manufacturing companies. They're all over the map as well. Even that's not enough. We have about 24 members that are companies that are organizations, I should say, that are research organizations such as CSIRO, which is the Australian research organization, the World Economic Forum, which you may have heard of, that runs the Davos conference, which has a lot of ideas about what the future of Internet of Things is in industrial systems. Universities, the first of this pack to join was Technische Universität Darmstadt, for example. And government agencies. For example, in the middle of the slide, you have NIST, the National Institute of Standards and Technology in the United States, and CAICT, the China Academy for Information Computing Technology. What they're bringing to the table is an understanding of what the market needs, an understanding of how the government regulation is going to affect what we do. Our process is pretty straightforward. Our process is to bring together that ecosystem, develop the use cases of how we're going to apply Internet of Things technology in industrial systems, then develop architectures, something we call the Industrial Internet Reference Architecture, but at the same time, with our Business Solutions Group, figure out what the business impact is going to be and how we're going to restructure our businesses to take advantage of these disruptions. And then build test beds. What's the point? The point is to find out where the disruptive products and services are that come out with those transformational business outcomes, and then also develop requirements and priorities for new standards and feed those to standards organizations. We have, at this moment, 14 public running test beds, and information about all of them is on our website. I'm going to give you a pointer to the website at the end. At the moment, about 9 non-public, which will be coming out later this year, and roughly 20 more test beds that are under development that we expect to go public by the end of the year. I'll just talk about a couple. The first test bed that we announced, which was a year ago at Bosch Connected World in Berlin, run by Bosch, Tech Mahindra, and Cisco, attempts nothing less than to reinvent the manufacturing floor. In a factory, if you know exactly where everything is, the people, the parts, the work in progress, and the tools, you can make the floor more efficient, and you can make the floor safer. You can know that the person is picking up a tool that he's not been trained on, or taking it out of a geofenced area where it might be dangerous. That test bed has actually been tremendously successful. It is already generating requirements and priorities for standards organizations and open source organizations. And they're moving into a second phase now, where rather than locating everything on the factory floor within about a meter, they will instead locate everything on a factory floor within 3 millimeters. So you know that the right bolt is being put into the right hole on the work in progress. But this technology has very wide applicability in industrial systems. We also have in Southern California a test bed which is led by National Instruments, RTI, and Cisco, which is attempting to reinvent the electric grids, something called smart grid. Working along with the smart grid interoperability platform, they are actually building small grids, test grids now in Southern California, which will be rolled out in San Antonio, to figure out what can we do if we make the grids smaller, the same way that we made radio telephony cells smaller in the 1980s and created the enormous boom in wireless telephony. We're also working in the area of smart cities, although in this case it's a smart county. And that is, if you could integrate national information, for example, national healthcare information in a country like Ireland, with provincial information. The provinces in Ireland are called counties. In this case, it's County Cork. This project, led by EMC, is actually looking at how we could take advantage of connecting the healthcare information at the national level and the ambulance management information at the provincial level, and make sure when the ambulance arrives at your home, they already have your healthcare data. Think about the lives saved from that process, and the lives saved the other direction when the information is uploaded back to the hospital directly, and they know about the incoming trauma before the person arrives in the emergency ward or emergency room. We have projects looking at condition monitoring and predictive maintenance. We have projects looking at high-speed networking and what you could do if you had 100 terabit connections between research centers rather than just a couple of gigabits per connection. This one led by General Electric. An asset efficiency testbed led by Infosys with Bosch, Intel, and PTC, which is looking at organizations that have millions or billions of assets and can't keep track of them. And that is banks, and it's manufacturers, and healthcare companies, and a million other companies on the planet. Once we have results from this process, we can do something intelligent like, say, standards organizations. Now we know where the standards requirements are. Now we know where we have to provide interoperability. Now we know what privacy we have to take care of. And we have relationships with about 24 standards organizations and open source development organizations to solve those problems. Why today? It's not because the technology is new. On the floor out there, there will be at least one vendor that tells you that Internet of Things is new. It's not. It's a convergence of forces, low-cost computing power, ubiquitous connectivity. It's hard to find a corner of the world where there's no internet connectivity anymore. And it's not about how many connected devices there are. A lot of presentations start with there's 70 billion, 200 billion, a billion, whatever, connected devices. What's interesting is what I do with the fact that they're connected, and what I do with it is real-time predictive analytics. That's the big change. So what does the future look like? I'm just going to give you one example, and it's my favorite example. Anybody know what that device is over on the right-hand side? Anybody ever had one of those clipped to your finger? I see a few nodding heads, and I'm sorry, because that means you've been in the hospital. That is a device that looks through your skin and guesses how much oxygen is in your blood. I really mean guesses, because the average correct result is only about 80% of readings, which means that you get lots of warnings from these devices which are incorrect, especially if the nurse has put the blood pressure cuff on the same arm. If he or she did, then when the blood pressure cuff blows up, obviously it stops blood flow to your finger, and the device on your finger says that you have no oxygen in your blood, and it means you're dead. That's not a good thing, by the way. And that's reported to the nurse, and the biggest problem in healthcare today is too many alarms. We could obviously connect this device, the blood pressure device, with the blood oxygen device. But in fact, nobody does that anywhere, in any operating theater, anywhere in the world, because they're made by different manufacturers, they sit on different networks, they speak different protocols, and interoperability between them is difficult. It's in the lab in a few countries. Here in Germany, I've seen it also in the US and in Japan. But we have to solve this in a way that's consistent worldwide, because it will not only save liability, but it will save lives. And we think that's important. The good news is things are actually coming together. We have, as I said, 14 public test beds, far more information on our website. And I think that we're going to see a world where I said devices don't fail anymore, or if they're going to fail, you're notified of it before it happens. And I think that means the opportunity is enormous. We're already seeing it today. People ask me, is this something I should think about for 2025 or today? Well, I'll tell you. I have a friend in northwestern Costa Rica, in the state of Heredia, the province of Heredia, who has a dairy farm. He has the same cows as his neighbors. He has the same terrain, obviously, as his neighbors. But because he monitors his cows on a minute-by-minute basis, and he knows their health, and he knows their love, and knows if they're pregnant, and he knows how much milk they put out every day for the last 10 years, he generates 40% more milk per cow than his neighbors. That's today, not tomorrow, not next year, but today. So the good news is that technology works. The good news is that technology has been proven. And the good news is this technology, even if it's hype, and it certainly is hype, is not only hype. So if you'd like to know how to participate, by all means, come to our website. We'd love to have you learn more about how to apply Internet of Things in industrial systems. And when I say industrial systems, I mean any large system. I see a future where we integrate trading information from trading desks all over the world with exchange information and do real-time predictive analytics and say, this looks like 2008, September of 2008, or November of 1929. Or say October of 1987. Those are bad years. For those of you who don't know, that's because you haven't invested enough money. And give a warning to people that run the trading desks and people that run the stock exchanges that this looks like another meltdown. Finance, healthcare, manufacturing, transportation, life sciences, many, many, many different areas where we can track what's happening in real time and make decisions in real time and make changes in real time. If you'd like more information, this is how to reach me. I'll be here the rest of today. And this is how you can reach me if you don't catch me today. And I apologize for the picture, which was taken 35 kilos ago. Thank you.